So the assignment we're going to be going over today is in the Balancing Chemical Equations folder, and it is this Understanding Chemical Equations assignment. So this is what we started yesterday. When you click on this, when you click on this, all right, if you missed yesterday or you're unsure or you have questions and you need more help, it's all right here. So this video is from what we did yesterday up through what the homework was supposed to be last night. So make sure you watch this video if you need help, or come to my office hours and I can help you today. So Withrow Pescatris OH 2:20 to 3 p.m. All right, so this is where you are. Everybody clear on that? Your assignment should look like this. All right. So for here, I'm going to go through this kind of quickly because, like I said, you should have it done for homework, and all you should be doing is checking to see if you have this right. All right, so first up, let me scroll down a little bit. We got potassium K and chlorine Cl. So in this box, I'm going to put K, Cl. I'm going to copy that. Oops, wrong button. Paste it over here because I will have the same elements in the reactants as I do the products. The coefficient in front of the K is a 2, so that means there are 2 potassiums. So I'm going to put down a 2 here. And the subscript after the Cl means that there's 2 chlorines. When I go over to the other side, I have a 2 in front of KCl. So that means that there are 2 of everything in here. So 2 Ks and 2 Cls. Now I check 2, 2, 2, 2. Everything is equal, so this one is balanced. Next up, you have Ca is the first one. C is the next capital letter. And then O is the last one. Again, I just copy and paste this because they're going to be the same on both sides of the equation, but the numbers are going to be different. So, because there's a 2 in front of this whole thing, all right, it's like saying that there are 2 of everything in here. So there's 2 CAs, there's 2 Cs, and there's 2 O3s. So that would make 6. Because 2 times 3 makes 6. Next, I go to the product side. I have a 5 in front of all this stuff. So I have 5 CAs times 5 Os. Or 5 Os. So I have 5 here and 5 here. Now, over here again, I have a C. I only have one of it. There's no coefficient and no subscript, so it's only 1. However, this is tricky. Look, you have 1 O, or you have 2 O's here, and you have 1 more over there. It is the total number of oxygens on that side of the equation. So if you have 2 belonging to the CO2 and 1 belonging to the CaO, that means you have 2 plus 1 makes, well, I'm sorry, this should be a 5. So 5 times 1 plus 2 is 7. All right. So you can start off right away and see that the calciums on the reactant side is not equal to the calciums on the product side, so this is unbalanced. Finally, down here, list everything you see. I see an I. Next is NA. Remember, NA comes together because it's capital then lowercase. The next symbol I see is an S. And the final symbol I see is an O. I'm going to copy paste because the atoms will be the same. They're just going to be they might be in different numbers. So now that I'm going to count, I have 2 on the I, so I'm going to put a 2 there. I have a 2 in front of all of this business. So that means 2 Na2s, 2 S2s, and 2 O3s. So I'm going to put 2 times the subscript is the easiest way to do this. So 2 times 2 makes 4. 2 times 2 makes 4 again. And 2 times 3 makes 6. Hop over to the other side. I'm sorry, well, let's start with I's so that way we keep this lined up. So in I only see 1 total. Okay, oops, wrong button. 1 here. NA's, now remember, you have 2 over here, and then you have another 1 over here. So 2 plus 1 equals 3. Next, I'm going to look at the S. I only have a 4, and that's the only place it shows up. So 4 it is. James, I'll get to you in a second. And then finally, I have 6 on the O's. And that's the only O I see. So O is balanced, S is balanced, NA is not balanced, and I is not balanced. So this whole thing is unbalanced. All right. Now again, if you got any of that wrong, it's okay. Hopefully you were able to correct that as we went through it. So James asks, is it possible for something to have a physical change and a chemical change simultaneously? Let's see. Well, by default, a physical change keeps the object the same. So technically, no. All right. So if you have, let's say, let me try to think of one. All right, I got you. So, have you guys ever used those hand heat warmers before? Have you seen those? Heard of them? They're like little white packs. Okay. So inside those, you have 2 chemicals. I can't remember exactly what they are. I think one's iron, and I can't remember what the other one is. However, when you shake them up, you mix the chemicals, which starts a chemical reaction that gives off heat. So you're creating inside that pack a new substance. So James, that is a chemical reaction there. However, to answer your question and make it fit, you can use that heat then, say you use that heat to melt some water or melt some ice. That is creating a physical change in the water that's not combining with the hot pack. So you can use the heat produced from a chemical reaction to create a physical change, but they cannot happen in the same thing at the same time. That make sense? That's a good question. All right. So next up, we should be down here. So let's go click on this link. And then when you should see this page, click on the introduction, and it should look like this. One more time, click on this link. It should open to this page here. Click on this first introduction square. I'm gonna give you guys a second to get there. So the first question says here, all right, what can you change, about this simulation? So play around with it. So click on this and click around to see what you can alter. And let me know in the chat when you find something you can. Remember, I'm trying to give out Robux here, so if you are participating in class, I'm giving out Robux. What is something you can change on this screen? You can say it out loud or put it in the chat. All right, so Ariel, you can change the chemical equation we're working on. So that's one thing you can change. All right, so up here, what that means is, again, every time I want complete sentences, you guys are all smart kids, so I want you to talk like it. You just write this. You can change the type of reaction. What else? Andre, what's something else you can change here? Try clicking around on your screen. What's something that you can change on your screen? There you go. That's not right. Tools. All right. So to do the tools, click on this scale here. That's the next step. We're going to get you ahead. So make sure you click on the scale and it should look like that. All right. So that's the next thing you write down. Type of reaction, tools, and there's one more big thing I'm looking for. All right. Let's go with Brianna. What is another thing you can change about the simulation? All right. Jalen, you're up next if she doesn't say anything. All right. Okay. Jalen, that's correct. Good job. You're gonna get her Robux that I was gonna give out. All right. So you can change the weights here by clicking on these numbers. So make sure you click every one so that it has a number 1 in it. That's how we're gonna start this out. All right. So I'm gonna walk you through the first one. I'm going to ask people to do the second one. Good, Jalen. And then on the third one, you guys are going to do that on your own. So I will say again, I said this yesterday too. If you are like ahead, if you get this and you understand what you're doing, and it makes sense to you, go ahead and work ahead, knock this out. Okay, I don't want to hold you up. So if you understand what you're doing, go ahead and knock it out. If I call on you, you should already have the answer on your screen, and all you gotta do is say what you got. All right. So first up, what we're gonna do is, and again, like the whole reason we did Sudoku in the warm up, and why I told you yesterday, I want you to think of this like a game, is these symbols NH and NH3 are all chemistry. However, if you take your brain out of chemistry mode and you just put them as like this is a symbol, and I have to make this symbol match the number of symbols on the other side, it turns into a game, and this is a lot easier and enjoyable actually. So that's what I'm looking for you guys to do. So don't think about the chemistry until we're done with the problem. So step one is you're going to choose a symbol to try to balance. We're going to start with N on this one. The left side of each scale represent the reactants. So it represents what's on the left side of your screen here. you have two N's, N2, and you have two H's, H2. Now the two N's on the left side are more than the one N in the NH3 molecule on the right side. So what you want to do is you want to try to get these to be equal. So you always start on the lower of the two symbols you're trying to balance. So N, you have two N's on the left side and you have one N on the right side. The lower of those two is the number 1. So you ask yourself, is it possible to multiply the lower number by a number to equal the other number? That's the easiest way to do this. So how you do that, if it's possible, you're well on your way. So what times 1 equals 2? That should be easy. 2 times 1 equals 2. So what you're going to do is you take the number you multiplied by and you put it in front of where you find that element. So you see n here on this side of the equation. Remember, that is the lower side. It has 1. So you see n on this side. I'm going to make this a 2. And by doing that, we balanced n's. Excuse me. However, you unbalanced the h's. You made that even worse. And I'm going to tell you right now, that's okay. That's what's supposed to happen, because sometimes it's the easiest way to figure out what to do next is to mess up other ones. So I want you to think about this like you're inviting a friend to a party, right? And let's say if you're inviting like your cousin to a party, but your cousin has like these 2 or 3 friends that like always hang out with them, and they're good. You can just assume that they're going to come because you invited your cousin, right? So that's kind of what happened here. Is if nitrogen is the cousin you want at your party, and hydrogen are its 3 friends, if you invite your cousin, you're going to have to invite the friends too. So that's what's happening here is when you say there's 2 NH3s, you're getting your 2 N's, but you're also doubling up on your hydrogens as well because they're bonded together. If they're bonded together, whatever you change on one of them will change the other one. So now you got to go to the lower side. You have 6 on the products and you have 2 on the reactants. 2 is the lower number, so you're going to go over here, and this is going to be the number you're changing. You have to ask yourself, is there a number that I can multiply by to get to 6? So 2 times what number is 6? Thankfully, that's an easy one. 3. Good job, Kasia. So I'm going to put a 3 here. Wham bam, you balanced it. Everything is equal on both sides of the equation, and you're done. So what you're going to do now is take a screenshot of this picture. The screenshot buttons are Windows, Shift, and then you hit S one time. Hold down Windows, hold down Shift, hit S. The Windows key is that white square in the bottom left corner of your keyboard. And you click and drag until you can capture everything inside that rectangle that you want. And it should be everything from the smiley face down right above the chemical reactions you can change to. So that's where you start. Now I'm going to go back over here, and I'm going to paste that in this box. Print screen is okay, but the main benefit of doing that, what I did, is that it automatically puts it on your clipboard, and then I don't see what all the thousands of tabs you have open or whatever programs you're running on the bottom. It only takes a picture of just what I'm asking for and not the whole thing. Because the print screen is literally everything on your screen. So like I can just hit Control V to paste in this box, and I don't have to like go find the print screen. So my numbers were also 1, 3, oops, 2. So this is how the first one should look when you're done. Now if you have the 1, that's okay. But you can also, it's also correct if you delete it, because like in math class, if you multiply something that's inside parentheses by a 1, technically you don't have to write that because it's going to be whatever's inside the parentheses anyways. So you don't have to do that. So this is all you need to do. All right. So tonight to finish, I want you to try these two on your own. I'm going to be recording a video or posting a video of what we went over. Make sure you answer these questions. And then for the game, it is level 1 is required, but level 2 and 3 are extra credit. And you need to get 3 stars or better for it to count. And you can find the game by clicking on this button down here where it says game at the very bottom of your screen. And then level 1. Okay. So hopefully this helped you guys understand this more. Again, I'm begging you, come to my office hours if you need help or you're behind. I will help get you caught up and where you need to be so you don't got to worry. All right. I will see you